Now we have created our cluster, everything's cool and fine, so we should have a 30 billion ADA available for us, and the thing that we are going to do now is to actually move those 30 billion ADA from the Genesis UTXO where they are right now to regular UTXO. And for that we are going to generate a new key, a new signing key, and a new address that will receive the funds. So what do we have here? Okay, I'm in the wrong directory. Okay, so I'm gonna use Cardano CLI keygen -- secret, and this is because we are in Byron era. We have different commands to generate keys in Shelley eras, but since we are in Byron, we need to use Cardano CLI keygen -- secret UTXO keys, where that is where I'm gonna store this key. This is the directory, and payment 000 key. Perhaps I chose a poor name because I already have a 000 for my delegates, but it doesn't matter. It is, at least it says that it is a payment key. And let me just generate the address for this key. So we use Cardano CLI signing key address -- test and magic 42. The secret, that is the key that we just created, and we are going to output this. We don't have an option, a flag, as we have in the Shelley commands to redirect the output to a file or to save it to a file. We need to use the bash trick to actually redirect this output to this file that we are going to create. So there you go, we have created the file. So if you treat the UTXO keys, we have these newly created keys and key and address. So this is where we are going to send the 30 billion ADA that we had available in our Genesis UTXO. So and if you wonder how do we know it, well, that's because we said that, but also it is in the Genesis file that we created with create Cardano. You can cat configuration Byron. So if we read that, you should see that this key contains the 30 billion ADA that we said that we wanted. So that's exactly it. That's the ADA that we are going to redeem into a regular address and UTXO. So let me just clear this screen again. So we are going to generate now the address of the of this UTXO key. So this was produced by this address was produced by the create Cardano command, this key. So we now need to derive the address for that. So just like what we did for our own key, this is what we're going to do, and we need it for creating the transaction, for building the transaction to retrieve those 30 billion ADA. So since we are going to create some transactions, not that much, honestly, it will take us probably 7-8 transactions to get to Babbage era, so it's not that much. But I want to keep a record of my transactions, so I'm going to create my directory, a transactions directory. And I'm ready now to start creating this transaction where we will spend the Genesis UTXO. So for that, we use the issue Genesis UTXO expenditure command. Cardano CLI issue Genesis UTXO expenditure. It will take as a parameter this the Byron Genesis file. It takes the testnet magic. It will produce this artifact, which is the tx0.tx file. Of course, you can choose any naming. I like this one. And the signing key that has access to this UTXO. So it is the wallet key, is the UTXO keys Byron 000 key. This was created by the create Cardano command. And the rich address, the address that has the funds, is the UTXO keys dash Byron 00.address that we just created a minute ago or generated a minute ago. And that is the source. That's the transaction input. And the output is payment 00 address, which is the address that we just generated here. Okay, so you may ask, why am I using the head command here for the Byron? Well, it is, let me just cancel this and show you how these files look like. So the first line is the actual address, and that's what we need. So therefore we need to use the head command to extract the first line of this file. So again, let me just copy that, and so we are going to send 30 billion to this address, 30 billion minus 1 ADA, so that we need to pay transaction fees. And since I have 30 billion ADA, I am going to be a little bit loose with the transaction fees, and to keep the amounts traceable, I'm just going to pay 1 ADA in fees, and that will be certainly more than enough. So ready to submit the transaction. Note that this is a different command than the one that you might be familiar with from the Shelley era. Now we use Cardano CLI submit TX, the testnet magic 42, and TX transactions TX0TX, which is the file that we just, and this is the output of the previous command, right? So this is the artifact, the transaction body that we are going to send, and there it is, transaction is successful. So unfortunately we don't have an explorer here, but yeah, trust me, the fonts have been moved to these other addresses. Unfortunately, right now we cannot really use commands like query UTXO for looking into the UTXO of this address. That will happen until Shelley era. But trust me, fonts are there, and I will prove that later with a different transaction. So right now we are ready to actually start upgrading our system. Remember that the first era of Cardano was Byron era, and Cardano Byron era actually has like two different implementations, two different protocols that we run, and we need to go through that. Right now the version that is run is the so-called Cardano SL. We are going to transition to Ouroboros BFT, and this is going to be our first update proposal, and please bear with me here, and let's see how these update proposals work. This is a command that we use to generate update proposals. Let me just type the command so that we will get the help from the CLI. And these are the options that it takes. It can take a lot of options, as you can see. So from all these options, we are going to choose only change the protocol version major one, because that's what we are going to do. We are now in protocol version 0.0.0, and we want to move to protocol version 1.0.0. Byron era also had this protocol version alt, which I don't think it was ever used, so it was there. This is why we know it as 1.0.0. This thing was removed in Shelley, so since Shelley we only have the major and the minor. So we can change basically any parameter of the updatable parameters, but right now we are just going to focus on the protocol version major, okay? And we are going to set it to 1. This is how we do it. So let me just come here and use Cardano CLI Byron governance, create update proposal. The file path is the output. So we will create this artifact, which is the update protoview1.proposal. So I like to be very wordy with my file names most of the time, because it tells me what it is about, right? So you could use whatever naming you want. Testnet Magic 42 again. The signing key for this update proposal. Remember that only the Genesis keys via their delegates can submit update proposals. If you try to submit an update proposal with a different key that is not in the delegate mapping, it will be rejected and it won't have any effect. So we need to sign it with this delegate key. We say that we want to go to protocol version major 1. Of course, by this time, the node already knows that when we change to the next protocol version, we are moving to Ouroboros BFT. This is already hard-coded and encoded in the node. And we are not going to touch the protocol minor nor the version alt, and the rest of the parameters are just a necessity. So there you go. And from now we are ready to actually, let me just shrink this again so that I could start creating my boats right now. But let me first, before I submit my boats, before I create my boats, I will submit the proposal. And I want you to take a look here, because we should see a nice message in the logs. So we see event ledger update, hard fork update in ERA, and we are moving to protocol update version 1.0.0, and the status of this update proposal is that the update proposal has been registered. So remember from our map here, from our diagram, our proposal has been registered. So it is now for us time to start accumulating votes. And this is exactly what we are going to do. Let me come back to my script here, and I'm going to create vote for my first delegate. Let me bring some space here. In Cardano CLI Byron governance, create proposal vote. So proposal file path. So I need to reference the same file that we just submitted in the proposal. I want to use testnet magic 42. Again, the signing key, which is the delegate signing key. We vote yes. And the output file is update protocol version 1.0.0.0 to identify my first delegate, the 00 delegate, and this will be a vote. The same goes for my other delegate. He produces his vote as well. Ready to go. And let me just clear this screen for a second, and let me come back to our diagram. So we are now going to submit our votes, and when we submit our votes, we should see a message saying that our proposal is confirmed, right? It happens when we accumulate sufficient votes. So let me just now come back to my script, and we are going to submit proposal vote. That this is a very special type of transaction. It is Byron submit proposal vote command. So this creates its own special type of transaction. This is not the case in Shelley eras. In Shelley era, you create when you submit a vote, or actually mechanism we saw that it is different. When you submit the proposal or the vote, you just use a regular transaction that pays fees and has to be signed by a payment key and all of that. So here we have this special type of transaction, and we see transaction successfully submitted, and we get the transaction ID for each of those. If we come to our logs, we should see what we expected. Ledger update, update confirmed. So we have sufficient votes. That's exactly what it means. We have sufficient votes. So yeah. Now let me just come to my diagram again. So right now we need to wait 2K slots In our system, remember, K was set to 45, so we need to wait 90 slots so that these transactions that contain the votes are deep enough in the chain so that we are comfortable saying that this will not change. There won't be any rollback that could remove them from the chain. So at that point, those transactions will be stably confirmed. So for that, we will need to wait 90 slots, and we know that our transaction was confirmed by slot 467. So by slot 557, we should see that it is a stable candidate, stably confirmed. Sorry. But since we have already submitted our votes, and because in our configuration file, this is something that I didn't mention before, but in our configuration file in the let me just make it a little bit nicer with JQ. We are already announcing in our sign blocks that we are ready to move to block version 1. That means that we are already endorsing the proposal. So by slot 557, we should have seen, and there it is, that we have a candidate. And that is because we are already announcing protocol version 1 in our sign blocks. So we have endorsed. So we didn't see this message because we had already endorsed this. So we jumped directly into the candidate. We had a candidate here. So our proposal has changed its status to a candidate at slot 557. And it means that we are ready to transition to Ouroboros BFT at the epoch transition of epoch number 2. So right now we have a candidate. So 2K slots later, 90 slots in our case, we will have a stable candidate. And it will happen by slot 647. So it will be in a couple of minutes. We should see this message: update the stable candidate. This is what we are expecting when we reach slot 647, which will happen in exactly 1 minute from now. So here we are just a few slots away from reaching slot 647, and when we reach that slot, we should see our update stably confirmed. And there it is. This is the message that we were expecting to see. Update stable candidate. And we are changing to protocol version 1.0.0 at the next epoch boundary, which, because we have 450 slots per epoch, it will happen by slot 900. So here we are very close to getting to slot 900, and this is where we expect the update proposal to be adopted, be applied. 2 slots more, and we should see a message in our logs again. There it is. Epoch transition occurred, and we have a message here that basically says that the ledger update took place. It was a hard fork update in error, and our Byron update protocol updates mapping is now empty. So we are good. We are now in BFT mode and BFT era. So from here, we want to actually go to Shelley. And to go to Shelley, you guessed it. Yes, you're right. We want to submit a new update proposal that will say that we are going to go to protocol version 2. So, but before I can do that, I actually need to update my scripts, the script that I am using to run the nodes. Since we are going to transition to Shelley, once we are in Shelley, those nodes, those BFT nodes, will require Shelley keys, right? Right now, they only have the Byron keys, and they will need the Shelley keys. They will need a CAS key, a BRF key, an operational certificate, and all of that that is common to block producers in Shelley era. So let me just come and update my scripts for BFT0. We are going to say that the Shelley CAS keys is the Shelley 00 CAS key, that this file was also created by the create Cardano command. It also created the BRF signing key together with the operational certificate. So this is what we are adding to the command that runs the node, and we'll do the same for BFT1. And of course, we will need to restart our nodes so that they pick up this new configuration. But just before we restart them, no, wait a second. I'm not gonna do this right now. I'm not gonna do this right now. Let me just go ahead and create my update proposal. So let me just clear this. So again, I'm gonna use the create update proposal command. So I will create the update protocol version 2 proposal. Again, it's gonna be signed by BFT0 signing key. Now I am saying that I want to go to protocol version major 2. I'm not touching minor, I'm not touching alt, and the rest of the parameters are just required. And now, let me submit the proposal. Oh, wrong. Submit, update proposal, submit, and we should see now for sure in the log messages that we have an proposal registered. That's the first step. That's fine. So now we want to create our votes. So let me just create my vote for BFT0, my vote for the other delegate, for the delegate 1, and let me submit my votes again with submit proposal vote, and I'm going to submit the update protoV2 that we just created, the votes that we just created. So now we should see that the update proposal is confirmed. It has accumulated sufficient votes, and it occurred at the slot 1045. So by slot 1135, we should see that our proposal is now stably confirmed. So here we are. We are 4 slots away from our target, which was 1135. I mean, slot 1135. And I see that the message has shown up here. So we see that our protocol update proposal to go to version 2.0.0 now has a new state, and it is stably confirmed, meaning that it is at least 2k blocks deep. So here it is. So now if we go back again to our diagram here, we see this, and we are going to start accumulating endorsements. And again, by endorsements, we need to say now in our blocks that we are signing that we are ready to move to protocol version 2. So with that, that will be an endorsement. So how do we do that? Let me go back here to my script. I remember that I said that I was going to skip one of the lines here? Well, this is exactly what it takes. We are going to modify our configuration file for the node, and we are going to say that we are happy to move to version 2. And of course, I am running a node that understands all the way from Byron to Babbage. This is why I can use the same version of the node all the way up. If this was happening on real time, this would be for me the time to get an update for my node, get the latest version, which will be configured or prepared to understand version 2, and then restart my system with that new version of the node, my node with the new version. But since this version that I'm running understands all the current eras, well, I don't need to update my node. So let me just go and update my configuration file so that we say that we are happy to move to version 2. And now I need to restart my nodes so that they pick up the Shelley keys that we just configured before and this change that we made in the configuration file. So let me start by BFT0. I'm gonna Control C to stop it. I'm gonna run the starting script again, and there we go. We are our blocks will be now saying that we are happy to move, and we go and do the same for BFT1, and we should see a message. Once we have accumulated enough endorsements, we see the message that we have a candidate, right? So what this means is that we become a candidate at the slot 1216, meaning that 90 slots later, 1306, we will have a stable candidate, and we will be set to transition to Byron era at epoch number 4. I guess we don't have sufficient time for the transaction to be deep enough, the endorsements to be deep enough by the next epoch transition. Therefore, it is delayed by 1 epoch. So, but that's great because we see here the other piece of information that we see that the hard fork update transition is confirmed, and it will happen at the epoch boundary of epoch 3 transitioning to epoch 4. So we have a full epoch to wait, and that's totally fine because that gives me time to go and have another coffee. See you in 1 epoch. So here we are almost there. We are just about to reach the epoch boundary between epoch 3 and epoch 4, and that's where we expect to see the Shelley hard fork in our local cluster. So we are just 5 slots away from it. This is the moment where you feel nervous or you pray for it. Nah, just joking. We are confident about this, and that is just happening. So let me just catch it. As you saw, we have quicker slots, 20 times faster slots, so that is why logs started just to fly off the screen. But we have the piece of log that we were looking for. So we have ledger update, Shelley era index Shelley epoch number 4, and what we have is the hard fork update transition is done. This is the message that we were expecting, and this is, we have also confirmation and on this side that we are in Shelley era. And now our slots are lasting not 2 seconds, but a tenth of a second. So congratulations, we are in Shelley era, but still in a centralized block production. That is that there is no stake pools. We need to create a couple of stake pools, at least one, so that we can leverage the powers of Shelley. And so the first thing that we're gonna do right now that we are in Shelley is move our 30 billion, I just killed a mosquito, our 30 billion ADA from the payment address that we just created in Byron, we are going to move them to a proper Shelley era address, and this is the proof that I promised that the previous transaction that we couldn't actually see, we just trusted it. That is the transaction that where we are going to demonstrate that the funds were actually moved in the transaction, and we will, from there, we are going to be able to distribute some funds to our stake pool owner and to other addresses that we are going to need. So I'm going to take a break and see you in a minute, where I'm going to start creating a stake pool in our system.